So welcome. This is test 3 based on derivatives IBAHL. So the first question is asking us about to find the show that the function is increasing and determine whether f inverse of x exists or not. So to know whether it is increasing or decreasing, what am I going to do? Find the first derivative. So quotient rule 1 minus 2 e power 2x whole square, then 1 minus 2 e power 2x times e power 2x derivative is 2 e power 2x minus 1 plus e power 2x as it is, negative 2 e power 2x derivative is negative 4 e power 2x. Now expand that 2 e power 2x minus 4 e power 4x plus 4 e power 2x minus plus 4 e power 4x divided by 1 minus 2 e power 2x whole square. Then 4 e power 4x gets cancels, which becomes 6 e power 2x upon 1 minus 2 e power 2x whole square, which is positive. Therefore, it is increasing function. Hence, f is increasing. The first derivative is positive. Now, it is a one-to-one function. We know that f is one-to-one function, one-one function, one-one function. Since it is increasing, always it is increasing, it is going to be a one-one function. So therefore, f inverse will exist. If at all it is a one-to-one function, f inverse will be existing. Question number 2, find the derivatives of this one. Part A, e to the power of ln x derivative is e to the power of ln x, square root ln x, 1 upon square root x derivative. Remember, 1 upon square root x derivative is always 1 upon 2 square root x. 2 ln x, 2 square root ln x. Ln x derivative is 1 upon x. 2 tan square 3x derivative is again 2 tan 3x. Tan 3x derivative is secant square 3x. 3x derivative is 3. So what will be the final answer? E power square root ln x divided by 2 square root ln x, 2x square root ln x plus 12 tan 3x secant square 3x. That is f of x. Now g of x. What is g of x? 3 square root of x square plus 1. So it is 3 2 square root of x square plus 1 times x square derivative is 2. So what does that becomes? But it is minus half, so we cannot use that formula. So therefore it is negative half, so it becomes minus 3 upon 2 x square plus 1 whole power minus 3 upon 2 times x square derivative is 2x. So it becomes 3x, negative 3x, x square plus 1 whole power negative 3 upon 2. Part C, which is h of x. What is that? 23 to the power of x. 23, let me copy, 23 to the power of x plus log x to the base 23 can be written as ln x upon ln 23 plus ln 23 to the power of x upon ln 23. So now the derivative will be 23 to the power of x derivative will be 23 to the power of x ln 23 plus ln x derivative is 1 upon x and 1 upon ln 23, and this one when I simplify it becomes x ln 23 upon ln 23. Ln 23 ln 23 gets cancels. X derivative is going to be 1. That's going to be the answer. Part D, ln x to the power of x is x ln x, and this is half ln x, half ln pi, or else you can keep it as ln square root pi only. Ln square root pi, x ln x derivative, x ln x derivative, x times 1 upon x plus ln x times 1 plus ln pi derivative is a constant 0. So answer is 1 plus ln x. Now coming to the next question. Show that from first principles 2x cube plus 5 upon x minus 1 is this one. So f prime x equals to limit h approaches 0 f of x plus h minus f of x upon h. Now limit h approaches 0, 2 of x plus h whole cube plus 5 upon x plus h minus 1, then minus 2x cube plus 5 upon x minus 1 divided by h. I try to expand it out. Limit h approaches 0. It becomes 2x cube plus 6x square h plus 6h square plus h cube minus 2x cube. Then I take these two together. The common denominator, or else 5 upon x plus h minus 5 upon x, then minus 1 plus 1 divided by h. Minus 1 plus 1 cancels. So I grouped these two terms together, like terms. So that easy for simplification. Then 2x cube gets cancels. So limit h approaches 0, 6x square h plus 6h square plus h cube. And when I simplify this one, directly I'm writing it out, or else 5x minus 5h upon x plus h times x, then upon h. Again 5x cancels. Now try to eliminate h. We can see every term is having h, 1h gets cancels, and 1h gets cancels. So what am I left over with? Limit h approaches 0, 6x square plus 6xh plus h square minus 5 upon x plus h times x. Then plug in h as 0. So it becomes 6x square plus or minus 5 upon x square. Wherever h is there, write 0. That's going to be the answer. Question number 4. Find dy by dx. So dy by dx will be g prime x times ln x plus g of x times 1 upon x. Plug in dy by dx at x equals to 2 will be g prime x is nothing but what? 2 times ln 2 plus g of x. G of x is nothing but how much? 4. 4 times 1 upon 2, which is going to be 2 ln 2 plus 2. Next is part B. Again dy by dx. Dy by dx equals to 1 upon g of x, and g of x derivative is g prime x. Then again at x equals to 1. Dy by dx at x equals to 1. So g of x at x equals to 1, which is 3, and g prime x at x equals to 1 is 5. So which is 1 upon 3 times 5, which is 5 upon 3. Then part C. Dy by dx equals to g prime of ln x. Again ln x derivative is 1 upon x. So now I want dy by dx at x equals to 1. So it becomes g prime of 0 times 1 upon 1. G prime of 0 is 3. 3 times 1 is 3. That's going to be the answer. Question number 5. The line y equals to minus 4x plus 1 is a tangent. Find the values of m and n. So what am I going to do? I am going to find f prime x, which is 6x square plus 2nx. And I am going to find g prime x, which is minus 4. Let this be g of x and let this be f of x. Now what it says, at x equals to 1 they are same, so they should be having same slopes. F prime of 1 should be equals to g prime of 1. So 6 plus 2n should be equals to negative 4. 2n equals to negative 10, n equals to negative 5. Next, f of 1 should also be equals to g of 1. So 2 plus n plus 1 should be equals to minus 4 plus m. So 3 minus 5 should be equals to minus 4 plus m. So m equals to 2. So now the values of m and n are known. Find the normal line at x equals to 1. So at x equals to 1, find the y value, which is 2 minus 5 plus 1, which is minus 2. Slope of the tangent was negative 4. So slope of the normal will be 1 upon 4. So what will be the equation of the line? Y minus y1 equals to m times x minus x1. Part C. Find the normal line at x equals to 5 upon 3. So at x equals to 5 upon 3, the slope of the tangent will be f prime of 5 upon 3, which is 6 times of 5 upon 3 whole square minus 10 times of 5 upon 3, which is 0. So therefore, normal line is a vertical line. Is vertical. So x equals to 5 upon 3 is the answer. Question number 6. Find the first and second derivative of f of x. Simplify your answer. F prime x. Quotient rule. X power 3 whole square. Just getting off again and again. X power 3 whole square. X power 3 times ln x derivative is 1 upon x minus 3x square times ln x as it is. So it becomes, take x square common, 1 minus 3 ln x upon x power 6. So it will become 1 minus 3 ln x upon x power 4. Then f double prime x. Again, x power 4 whole square. So x power 4 times minus 3 upon x minus 1 minus 3 ln x times x power 4 derivative is 4x cubed. So I take this time x cubed common, minus 3 minus 4 plus 12 ln x divided by x power 8, which becomes 12 ln x minus 7 upon x power 5. Now, what is he asking? The x coordinate of the stationary point and determine its nature. So f prime x should be equals to 0. So 1 minus 3 ln x should be equals to 0. 3 ln x equals to 1. Ln x equals to 1 upon 3. X equals to e power 1 upon 3. Find the second derivative. In second derivative, if at all I substitute, 12 ln e power 1 upon 3 minus 7 upon e power 5 upon 3. So, which is going to be 12 times 1 upon 3 minus 7 upon e power 5 upon 3, which is a negative number. So therefore it's going to be a maximum point. For part C, find the point of inflection. So second derivative should be equals to 0. So 1 minus 3 ln, what was the second derivative? Second derivative was 12 ln x minus 7. 12 ln x minus 7 should be equals to 0. So ln x equals to 7 upon 12. So x equals to e power 7 upon 12. So that's going to be a point of inflection. We can check that one also. How do I check it out? At e power 7 upon 12, I'll find the second derivative value. It was 0 over here. So less than this one, I'll take e power 0. What is this? I'll take e power 0 and e power 1. At e power 0 it becomes negative, and at e power 1 it becomes positive. So therefore concavity changes. You can plug in e power 0 and e power 1 like in the last video. I have done it in detail. It concavity changes. So therefore it is a point of inflection. Question number 7. A cubic function has a maximum point. So let the cubic function is f of x equals to ax cube plus bx square plus cx plus d. Now, what is f prime x? F prime x equals to 3ax square plus 2bx plus c. F double prime x equals to 6ax plus 2b. Now, it says that it has a maximum at 0, 5, means f of 0 equals to 5 or f prime of 0 also equals to 0. If f of 0 equals to 0 means 0 plus 0 plus 0 plus d equals to 5, means d equals to 5. F prime of 0 equals to 0 means nothing but what? 3 times 0 plus 2 times 0 plus c equals to 0. So c equals to 0. Now point of inflection at 1 comma 1 means f of 1 should be equals to 1 or f double prime of 1 should be equals to 0. F of 1 equals to 1 means a plus b plus c plus d equals to 1. So a plus b equals to negative 4. F double prime of 1 equals to 0. So 6a plus 2b should be equals to 0. So 3a plus b equals to 0. I got two equations. A plus b equals to negative 4. 3a plus b equals to 0. Solve that. Negative, negative, negative. Minus 2a equals to minus 4. A equals to 2. Plug in a equals to 2. 2 plus b equals to negative 4. B equals to negative 6. So what will be the equation? 2x cube. I write in a new page. 2x cube minus 6x square plus 5 is going to be your f of x. Now part B, the coordinates of the minimum point and justify it is minimum. So find f prime x equals to 0, which is 6x square minus 12x equals to 0. 6x common, x minus 2 equals to 0. So x equals to 0 or x equals to 2. Now at x equals to 2, find the y value. Y value, I am directly writing it is negative 3. Now I'll find the second derivative at 2. When I find the second derivative, it becomes 12, which is positive. Therefore, it is minimum. Question number 8. The point A, pi comma pi, lies on the curve. Show that the curve passes through origin. So pi square plus sine pi minus pi square should be equals to 0. We get c value equal to 0. So therefore, 0 comma 0 lies on the curve. Then find the equation of the tangent line. So I'm going to find the derivative. So 2x, x square derivative 2x cos y dy by dx minus y minus x dy by dx equals to 0. Take dy by dx common, so it becomes cos y minus x equals to y minus 2x. So what will be dy by dx? Y minus 2x divided by cos y minus x. Now I am going to find at a pi comma pi. So slope of the tangent will be pi minus 2 pi divided by cos pi minus pi, which is negative pi by minus 1 minus pi. Minus minus cancels, pi upon 1 plus pi is going to be the slope. So equation of the tangent will be y minus y1 equals to m times x minus x1. Find the equation of the normal line at the origin. So at 0 comma 0, slope of the tangent will be 0 minus 0 by 1 minus 0, which is 0. So normal line will be y-axis. So because perpendicular to it will be, this is x-axis, so normal line will be y-axis, which is x equals to 0. Question number 9. The equal sides of an isosceles triangle. This is an isosceles triangle are 10 centimeters each. This side is x, we don't know. The angle theta is between the two equal sides and it is decreasing at a rate. D theta by dt is minus 0.1 pi. Find the moment when the triangle is an equilateral triangle, the rate at which its area is changing. Area equal to half side square sine theta. So half 10 square sine theta. So which is 50 sine theta area. Now dA by d theta or rate dA by dt equals to 50 sine theta derivative cos theta, theta derivative d theta by dt. But d theta by dt is minus 0.1 pi. So what does it becomes? Minus 5 pi cos theta. Now I want at dA by dt when it is an equilateral triangle. At an equilateral triangle, angle is 60 degrees, pi by 3, minus 5 pi cos pi by 3, cos 60. So it becomes minus 5 pi by 2. The rate at which the third side is changing. The rate at which the third side is changing. So third side, x square equals to, from your IGCSE cosine rule, 2 times 10 times 10 times cos theta. So x square equals to 200 minus 200 cos theta. So 2x dx upon dt equals to 200, derivative is 0, cos theta derivative is minus sin theta, and d theta derivative is d theta by dt. So 2 times 1, 2 times 100. So x dx upon dt equals to 100 sine theta. D theta by dt is minus 0.1 pi. So what will be dx upon dt? Will be minus 100 or minus 10 pi sine theta divided by x. Now when it is equilateral triangle, theta equals to pi by 3. And x also will be equals to 10 because all sides are same. So what it will be? Minus 10 pi sine pi by 3 by 10. So which is 10 gets cancels, minus pi sine pi by 3 is root 3 by 2. That's going to be the answer. Question number 10. Again, this is the graph for f prime x. He is asking us to draw the graph for f double prime x. Now this is a graph for f prime x, means this is the graph denoting slope. Let's do it out very slowly. Denoting the slope. Slope is positive over here. Slope is positive. Positive. It becomes a 0. What is this? It becomes a maximum over here, stationary value. So this is my point of inflection. This is my point of inflection because the slopes becomes, the rate of the slope is becoming 0 over here. So this A, B, C are my point of inflections. So remember, that's going to be my point of inflection, means second derivative is 0. This graph denotes the slope of the function. Now derivative of this one will become the second derivative. So it is, point of inflection is over here, point of inflection is exactly below that, and point of inflection is exactly below that. These are the point of inflection where the second derivatives are zeros. So that are the point of inflections. Now you can see that the point of inflections, now the slope is positive. The slope is positive and it is becoming 0 over here. The slope of this graph is positive. The slope of the first graph is positive and becoming 0. So slope of the first till the, what it says, first inflection point. Till the first inflection point, the slope of the graph is positive and becoming 0. So slope of the graph is positive and becoming 0. From the second inflection point to the third, what is this? From the first inflection point to the second inflection point, from here to here, what is this? The slope is decreasing. So slope is decreasing. Slope is decreasing. So it should be negative. From the second inflection point to the third inflection point, the slope is increasing. The slope is increasing, so therefore it should be positive. And again it continues to increase, and it continues to increase. This is the shape of the second derivative. How do I get the shape of the second derivative? Once again, see carefully. It's confusing to understand, I do know. So this graph denotes the slope of function. Slope of the function. Slope is positive, and but it is a decreasing function. It is decreasing over here. Slope is decreasing, slope is increasing. The slope is again increasing over here. The slope is increasing over here. I can write it out like this. Now, If I try to find the slope of this graph, it denotes the second derivative, where it is stationary over here. So these are my inflection points. Second derivatives are zeros at this point. Now from the y-axis to the first inflection point, the slope is increasing. But what is happening over there? It is positive and it is becoming zero. Positive and becoming zero. So this should be the shape of the graph. Now from the first inflection point from A to B, the slope is decreasing. Means its derivative also will decrease. Means it should be in the negative side. From B to C, the slope is increasing. So it should be in the positive side and become zero. Beyond C, again the slope is increasing. So it should be in this way. Draw a smoother curve. Coming to the function of the graph. We know that at point A, there is a point of inflection, and at point B, there is a point of inflection, and at point C also there is a point of inflection. Now, what is happening over there? From at point A, there is a point of inflection. Now, we should know where is the maximum point or the minimum point. Over here, the slope was positive and the slope became negative and it is zero. Positive, 0 and negative. So this point is going to be my maximum point. And over here it was negative, it became 0 and it became positive. Negative, 0 and positive. So this is going to be my minimum point. So after A, the point of inflection, there is a maximum point. After A, there is a maximum point. There is a maximum point. Then after B, there is a minimum point. The point of inflection, after B, there is a minimum point. And after C, again it is positive, positive. It continues to go on positive. This is the shape of the graph. So this is my maximum point and this is my minimum point. You can clearly see that positive. See the pink color one. The slope is positive, 0 and negative. So it is a maximum point. After A, there is a maximum point. So therefore, after A, there is a maximum point. And after B, it is negative, 0 and positive. So it is a minimum point. So after B, there is a minimum point. Now, question number 11. Show that by mathematical induction, the nth derivative is this one. So let's true for n equals to 1. So left hand side, f prime x equals to minus 1 upon x square minus 3 e power minus 3x. Coming to the right hand side, minus 1, 1 upon x square plus 3 e power minus 3x. So which is minus 1 upon x square minus 3 e power minus 3x. Therefore, it is true for n equals to 1. We assume it is true for n equals to k. Means the kth derivative is going to be minus 1 whole power k, k factorial by x power k plus 1 plus 3 power k e power minus 3x. Now we prove it is true for n equals to k plus 1. So my k plus 1th derivative will be minus 1 whole power k plus 1, k plus 1 factorial divided by x power k plus 2 plus 3 power k plus 1 e power minus 3x. So what is k plus 1th derivative? Basically, k plus 1th derivative means kth derivative's derivative. So minus 1 whole to the power of k minus k factorial k plus 1 divided by x power k plus 2 plus 3 power k times minus 3 e power minus 3x. So when I try to simplify that, I get, you can see that directly you can write that answer. You can take minus 1 common. See if minus common from here, minus 1 common from here. So this will become minus 1 whole to the power of k plus 1. Then k times k plus 1 factorial is k plus 1 factorial divided by x power k plus 2 and 3 times 3 power k is nothing but what? 3 power k plus 1 times e power minus 3x. So therefore it is proved. You can write the conclusion and get that answer. Now the same thing, question number 12, like the previous one. The rectangle ABCD is enclosed between x-axis and y equals to 2 root x. So what am I going to do? I am going to draw the 2 root x graph and a rectangle over here. And x equals to 9. X equals to 9 and this point is a comma 0 I take. So this point will be 2 root a because this is y equals to 2 square root x. And this is D, C, B, and I'll mention it out like this. Now the length. Length is going to be 9 minus a, width is going to be 2 square root a. So what is the area? 9 minus a times 2 square root a. So that is going to be 18 square root a minus 2a to the power of 3 upon 2. What is he asking in the next time? Find the exact maximum value of area and justify your answer. So I am going to find it out. Part B, ds upon dA, which is 18 upon 2 root a minus 2 times 3 upon 2, a to the power of 3 upon 2, 1 upon 2. So 9 root a minus 3 root a. Now, at the maximum or the minimum, first derivative should be equals to 0. So 3 root a should be equals to 0. 9 upon root a should be equals to 3 root a. So 9 equals to 3a. A equals to 9 upon 3. A equals to 3. Now find the second derivative. dA square. So will become minus 9 upon 2. A power minus 3 upon 2 minus 3 upon 2 root a. So which is clearly a negative number. So always, therefore it is going to be a maximum area. And what is that maximum area? Plug in that one. 18 times root 3 minus 2 times 3 to the power of 3 by 2. 18 root 3 minus 2 times 3 root 3. So which is nothing but what? 12 root 3. That's going to be the maximum area. Part C. Hence find the dimensions for y square equal to 4x. So it is going to be the same way. What is that? If at all I complete this one over here, I get a rectangle. So this will become nothing but what? 4 root 3. 2 root a, 2 root a, 4 root a or 2 root 3, and this will become nothing but what? 9 minus 3, which is 6. So C part, 6 times 4 root 3. That's going to be the area. And part D, again when will be minimum? When either a equals to 0 or a equals to 9. In that case, area will be equals to 0. That's going to be the answer. Area or s equals to 0. In that case, the area of the rectangle will be minimum, just like in the previous video. That's complete this paper. See you in the next paper. Bye.